Okay, so continuing with graphs of rational functions, now we kind of just bring everything together. And we're going to look at some graphs that have no discontinuities. So we'll start here. It just kind of goes over our rules again. So here are our rules for vertical asymptotes. They come from the zeros of the denominator. Horizontal asymptotes are not actually considered a discontinuity, but they still are an asymptote. And we have rules here that are based completely on the degrees of the numerators and the denominators. And then we have points of discontinuity, which comes from a zero of a factor in a denominator that gets canceled out. So there's an investigation here. We're going to skip it. It just kind of shows us a few different graphs that have no discontinuities. It's just important to remember that a graph with no discontinuities means there's no values that make the denominator equal 0. There still can be horizontal asymptotes. Because discontinuity basically refers to there's a jump. We have a graph that's flowing smoothly and then something happens. There's something in the way. Horizontal asymptotes help form the shape of our graph, but our graph is still continuous. Our graph is still one piece. So we're just going to skip to page 476 here and look at the examples. So here it gives us 10 functions, and we need to discover which ones have no discontinuities, which ones have no vertical asymptotes, which ones has no horizontal asymptotes, which one use the x-axis as a horizontal asymptote, which means the equation is y equals 0, which one have a horizontal asymptote with the equation y equals 1, and which one has no points of discontinuity, or which ones have points of discontinuity. So we'll go one at a time and see if we can figure out where to place these. So if we look at graph A, first of all, our function A, they're both already in factored form. Nothing can cancel out, so it won't have any points of discontinuity. We need to look for our asymptotes. This would have a vertical asymptote at x equals -4. Okay, well, all we need to highlight here is if some have no vertical asymptotes. So we need to look at horizontal asymptotes. So remember, for horizontal asymptotes, we need to compare the degree of the numerator to the degree of the denominator. Here the degree is both 1. That tells us we take the leading coefficients and we divide them. Well, the leading coefficients of both of these is 1. So this one has a horizontal asymptote of 1. So graph A falls into this category here. Let's look at graph B. Graph B, we could factor the numerator if we wanted to, but we can't factor the denominator, so there'll be nothing to cancel out. So there's not too many uses in factoring it. So let's look at that denominator. It can't be factored. It's x squared plus 4. There is no value that makes that equal 0. There's no factors that cancel out, so there's no points of discontinuity. There's no value which makes it equal 0. So right away, we know that there will be no vertical asymptotes. Since there's no vertical asymptotes and no point of discontinuity, that means there's no discontinuities. However, there could still be a horizontal asymptote. So we compare the degrees. The degrees here are both 2. Same degree means we divide the leading coefficients. Again, here the leading coefficients are 1. So this has a horizontal asymptote of y equals 1. Whoops, I put a of x in the wrong one here, didn't I? This was supposed to be a y equals 1. Okay, C, x plus 4 over x squared minus 2, or x squared minus 4, sorry. Well, this one can factor. Be x plus 2, x minus 2. Nothing can cancel out, so we have no point of discontinuity. But we do have 2 vertical asymptotes here at -2 and 2. Put x equals -2 and 2. And then I need to check for a horizontal asymptote. Well, I have my degree of my numerator is 1, which is less than the degree of the denominator. So that tells me there is a horizontal asymptote of y equals 0. So where does that fit here? Well, it has discontinuities because it has vertical asymptotes. And it has a horizontal asymptote of 0. So C goes here. D can be factored on the bottom. This time we can cancel something out. So we see that we would have a point of discontinuity at x equals -2. We have a vertical asymptote at x equals +2. And let's look for a horizontal asymptote. So same as C, the degree of the numerator is less than the degree of the denominator, so this has a horizontal asymptote at y equals 0. So where does that fit here? It has a point of discontinuity. It is the first one with a point of discontinuity, and it has a horizontal asymptote y equals 0. Okay, the next one can't be factored, but there would be an asymptote here coming from the denominator. But there's no point of discontinuity. If we look at the degree of the numerator and denominator, the numerator is 2, the denominator is 1. So here the degree of the numerator is higher than the degree of the denominator. So in this case there is no horizontal asymptote. So we'll see where this fits in here. So it has discontinuities because of the horizontal asymptote. Sorry, because of the vertical asymptote and the point of discontinuity. But it has no horizontal asymptote. So we can put that in here. And then it has no point of discontinuity. So E, I don't know why I put E of I. E only has horizontal asymptote. And here we can, I'm going to kind of go over here so we have lots of room. We can't factor the numerator, but we can factor the denominator again. Nothing can cancel out, so no points of discontinuity. We would have vertical asymptotes at x equals ±2. Horizontal asymptotes. Well, now we have the degree is equal from top to bottom again. So the horizontal asymptote will divide the leading coefficients. The leading coefficients are both 1. So it has a horizontal asymptote of y equals 1. So we are on F. F fits here. G. So when we have all these negative signs, sometimes it's easier to factor them out. Oops. Say that this is really what we're looking at here. Well, a negative divided by a negative really gives us a positive like this. So what does this have? Well, it has no zeros in the denominator, so there's no asymptotes, no points of discontinuity, which means we can fill this in one that has no discontinuities. We do still need to check if it has a horizontal asymptote. Well, the degree on the numerator is 1, degree on the denominator is 2. So we have a higher degree in the in the denominator, which means we have an asymptote of 0. So the x-axis is the horizontal asymptote. H. Again, it's probably helpful for H here. There's lots of negative signs if we factor out a negative sign. When we factor out a negative here, or -1, we do see that we can rewrite that denominator as a difference of squares. So we have a negative divided by a negative, so those can go. But this does allow us to see that we have this. So that allows us to see we have vertical asymptotes at positive and negative 2. That means we have discontinuities. There's no points of discontinuity. We can't cancel anything out. So let's just look at the horizontal asymptotes. The degrees are the same, so we need to divide the leading coefficients. Whether you divide from the original, -1 divided by -1, or from the simplified +1 divided by -1, we still get a horizontal asymptote of 1. So that is H. Next one. Well, now we have a difference of squares in the numerator. We have this non-permissible value that got cancelled out if x equals -2. So that means we have a point of discontinuity there. So we can fill I in here as having a point of discontinuity. Should be pretty obvious here without even comparing the degrees of the original that there'll be no horizontal asymptotes. Since this is represented now by a linear function, we all know linear functions have no horizontal asymptotes. So I goes into this category. Okay, last one, J. Here we can factor out an x first. And we can also factor the difference of squares. Well, now we can cancel two things out. But this gives us points of discontinuity at two values of x, 0 and 2. Oh, I made a mistake here. Sorry, I thought this was just x cubed minus 4x. Sorry, let's start this one over. I was reading this as minus 4x, not minus 4x squared. So we can actually factor out like that, so there is no difference of squares. So we're left with this. So the only thing I can cancel out is 1x. So there's a point of discontinuity at x equals 0, but there's also a vertical asymptote at x equals 2. So now looking at the horizontal asymptote. So this is a trickier one. So the horizontal asymptote, what is the degree now of the numerator? Well, after we simplify, the degree is 2. Because we have x times x minus 4. The degree of the numerator is 1. So our degree is higher in our numerator than in our denominator. So that tells us we have no horizontal asymptote. It doesn't matter whether you look at the degree after simplifying or before, the pattern will still be the same. So J fits into C, no horizontal asymptote, and it has points of discontinuity. Okay, example 2. Algebraically determine the equations of any asymptotes and the coordinates of any points of discontinuity of this function. So as always with rational functions, we start by factoring. So two numbers that multiply to 15 and add -15 and add to -2 would be -5 and 3. Okay, well right away we see that these cancel out. Should carry forward our non-permissible value. So we have a vertical asymptote at x equals -3. This is the equation of the vertical asymptote. The point of discontinuity is at x equals 5. So let's find the whole point. So we're going to find 2 times 5 minus 1 over 5 plus 3. So that's 9 over 8 is your y value. So the point of discontinuity 5, comma 9 over 8. Lastly, we should look for a horizontal asymptote. A horizontal asymptote, compare the degrees. Well, this is two binomial factors, so when we multiply that out, we know we're going to have x squared. That's the same thing as the degree in the denominator. So you could think of this in its expanded form to find the leading coefficient, or you could just multiply the first two terms together. If you want to multiply the whole thing out, you can, and you would get 2x squared minus 11x plus 5. Divide the leading coefficients, 2 divided by 1. So we have a horizontal asymptote at 2.